Alright, so for numbers 3 and 4, we're going to write a cube root function for the graphs. I did not take a picture of the graphs, but these are the points that we're going to use. If you look at your graph, you'll notice that our inflection point is at -1, -3, and the other dot that they marked is at -2, -5. The graph is counting by twos. Okay, so now with that, remember g of x is another name for y, so we're going to replace the g of x with -5 or -5. We're solving for a. X is -2, h is -1, so that means we're going to do minus -1, and then plus k, k is -3. I'm going to add the 3, move it to the other side, so that leaves -2 equals a times the cube root of -2 plus 1 is -1, while the cube root of -1 is -1. So this is -2 equals -a, so we divide by -1. So a is 2. Okay, so then you're going to write g of x equals 2 times the cube root of x plus 1 minus 3. Okay, so number 4, I did the same thing. I set it up so that you could see I identified hk and xy. And then this time they want you to use the equation with the b. So g of x is y, so I'm going to replace that with a 3. And cube root of b is what we're solving for. And then x is -1, h is -3, so minus a -3. Okay, plus k, so plus 2. I'm going to subtract 2. So 1 equals the cube root of 3 minus 1 is 2, right? So -1 plus 3 is 2, so 2b. So I'm going to cube both sides, so cube and cube. So 1 cubed is 1. On the right side we end up with 2b. So I'm going to divide by 2. So b is a half. So you write g of x equals cube root of 1/2 times the quantity of x plus 3 plus 2. So there's the other equation. Alright, so number 12 on page 426, it's a little tricky because if you don't pay close attention, you would think that this point right here is the inflection point because it's the point in the middle, right? There's 3 points marked, but in this problem, just be careful. This is your inflection point. That's the point where the graph changes direction. So you always have to be careful about that, okay? Don't just assume that that the middle point is always going to be the inflection point. In this case, that was not true. So for xy, you have two choices, -1, 1 or 6, 4. Again, we see that it doesn't matter what you choose. If you do the work correctly, either one works. So for g, I'll just use this one, okay, just because. And I'm going to have g of x is 4. We're looking for a. X is 6 minus a -2 minus 2. So I'm going to add 2 to both sides. So I get 6. Cube root of 6 plus 2 is 8. So cube root of 8 is 2. So this is 6 equals 2a. I'm going to divide by 2. So a is 3. So you write g of x equals 3 times the cube root of x plus 2 minus 2. Alright, so for 13, they gave you 4 points, right? Only one of them is the inflection point. So you just look at the graph and see where the curve changes direction. And in this case, it was at 2, -6. Okay, these 3 right here are the other points of the graph, but they're not the inflection point. So please make sure you understand how to find it, how to identify HK. It's the point where the graph changes direction. All right, so again, it doesn't matter which one you use. Just choose a different, I'll choose this one. Okay, you can choose the first one or the last one. You don't have to use the one I use. And so y is -8. We're looking for a. X is 3, -2, and then -6. Okay, for k. So I'm going to add 6. So I get -2 equals a. Now 3 minus 2 is 1. Cube root of 1 is 1, so a is -2. So you're done, pretty much. Just write the equation down. Cube root of x minus 2 minus 4. Sorry, minus 6. And there's the answer. Alright, so for 14, similar situation where they give you 4 points, but only one of them is the inflection point. So the one where the graph changes direction is this one right here, -4, -3. And pick one of the points on the right. I will choose this one. Okay, for my x and my y. So I'm going to put -1 because that's y. And then x is 12. H is -4, so it's minus a -4. And then -3. So I'm going to add 3 to both sides. And so I get 2 equals cube root of 16b. Okay, so 16 is not a perfect cube, so I'm going to cube both sides. So I'm going to cube here and cube here. So that gives you 8 equals 16b. Divide by 16. So 8 over 16 is 1/2, and that's your b value. So you're going to write g of x equals the cube root of 1/2 x plus 4 minus 3. Okay, for 22, the mistake that Tim makes is that he says that the graph is moved or translated 6 units to the left. Okay, so it's actually, this h is +6, so it should be 6 units to the right. He got the up 3 units, the 3 units up, he got that part right. For number 23, it's asking you why does the square root function have a restricted domain while the cube does not. Is it cube root? Sorry, it's cube root. Let me change that. Not cubed. So, like that. Okay, so I cannot have negatives inside the square root. Cannot have negative numbers in here because they are not real numbers. So this one is restricted to all x greater than or equal to 0 because you cannot have negative numbers inside a square root. Cube root, on the other hand, I could have negative numbers. For example, cube root of -8 is -2, so that's okay. Cube root of 0 is 0. And of course we can use positive numbers. So there are no restrictions on f of x. Number 24 is asking whether a translation, vertical or horizontal, will have an effect on the domain and range or range of the cube root function. Well, as you can see here, if we move it down here, it's still going to be all real numbers because the arrows indicate that it's going to move left and right forever and up and down forever. So no matter how you slide it, no matter where you draw it, you could draw it over here, you can draw it having a reflection over the x-axis like this. No matter where you draw it, the domain and the range will always be all reals. Okay, so the translation left, right, up, down does not have an effect on the domain and the range. Okay, on page 432 you have 4 problems. for number 1, tell whether each equation is the inverse of f of x equals x cubed minus 16. So let's find the inverse of this one. We would say y equals x cubed minus 16. I'm going to add 16 because I'm solving for x. So y plus 16 is x cubed. Find the cube root of each side. So now cube root of y plus 16 equals x. Switch the x and the y. And so now you write f inverse of x equals cube root of x plus 16. So that one is letter B. Okay, for number 2, we have to say whether each statement is true or false. So for part A, this is a square root function. It has that same shape as a square root function. H is 1 right here, and K is negative 2. So that means that the starting point should be at 1, negative 2. And if you see right here, this is 1, negative 2. And it is opening up towards the right, so this one would be true. For part B, it's asking whether the function has exactly one y-intercept. Well, actually this one is false because it has no y-intercept. It's never, ever, ever going to cross over here on this side because the arrow is going to the right. This is a dot where it starts, so it's never going to come over here on this side. So B is false. Okay, for C, it says the range is y is less than or equal to negative 2. Well, that would mean that the graph is opening down like this, but it's actually going up like this. So if I go from bottom to top on the y-axis, my first y on my graph is actually at negative 2, right here, it's right here, and then it goes up from there. So this one is also false, because it should be y is greater than or equal to negative 2. So for number 3, they tell you that the average rate, or the average speed of a plane going from one city to another is 550 miles per hour. So that would be like this one, going from point A over here to this side. And then on its return trip, it travels at 430 miles per hour. They want you to find out what is the average speed of the plane over the entire trip. So the plane went and then it came back. So it traveled this distance plus this distance, right? So in this whole distance, it went 550 miles per hour. Over here they went 430 miles per hour. So because the distances are the same, because it started in the same city and ended in the same city, then we could take the average of the two speeds. So 550 plus 430. And take, average, you add the 2 and divide by 2. And so that's going to give you 980. Divide by 2. So that's going to give you 490. So that's the average speed of the entire trip. Of going to the city and coming back. For number 4, they want you to find the inverse model for this equation. E is the kinetic energy and S is the speed of the car. So when you're dealing with real life equations or real life situations, you don't follow the 4 steps when you're looking for the inverse. Basically what we're doing here is we're going to solve for S, and we're not going to be switching the E and the S, only we're going to be solving for S, and that will represent the inverse model for this situation. So the first thing we're going to do is divide by 625. Okay, and so now we have E over 625 equals S squared. Well, we want S by itself, so we're going to take the square root of both sides. So now we have S equals square root of E over 625 is a perfect square. Its square root is 25. Okay, so this is the inverse of this. Okay, so these two are inverses of each other. Now the second part of the equation is if the kinetic energy doubles, will the speed double?